Hello students, in this session we are going to discuss the most important MCQs which asked for the board exam for the last 7 years from the chapters electric charges and fields, electric potential and capacitance, current electricity, moving charges and magnetism. So let's move on to the first question. If the net electric flux through a closed surface is zero, then we can infer no net charge is enclosed by the surface. Uniform electric field exists within the surface. Electric potential varies from point to point inside the surface. Charge is present inside the surface. Look at the question, net electric flux. You know that according to Gauss theorem, net electric flux phi is equal to 1 by epsilon naught into Q net, where Q net is the net charge enclosed. Net charge enclosed. It is given that the net electric flux is 0. So phi is 0 means for that Q net should be 0. So what is the condition for the flux to be 0? The net charge is enclosed by the surface should be 0. That means you can clearly see that is our first option. So first option itself is correct. So A is the right answer for this question. Very simple question based on Gauss theorem, chapter 1, electric charges and fields. Question number 2. An electric dipole consisting of charges plus Q and minus Q separated by a distance L, look at that, L, is in stable equilibrium in a uniform electric field E. The electrostatic potential energy of the dipole. This is a direct question. Electrostatic potential energy of a dipole. Do you remember the formula? The formula for electrostatic potential energy is U is equal to minus of P dot E. This is the formula. What is P here? Dipole moment, and E is the strength of electric field. So this is minus of what? Pe cos theta. Pe cos theta. This is the formula for electric potential energy. But here it is given, it is in stable equilibrium position. We have two equilibrium positions, hope you remember. One is stable, another is what? Unstable. In stable equilibrium position, theta is equal to 0 degree. In unstable, it is 180 degree. So here, stable equilibrium. So theta is 0. You can substitute, which is equal to minus P. What is cos 0? Cos 0 is 1. So we get minus P. But it is in terms of charge and distance. What is P? Dipole moment. Dipole moment P is equal to the product of charge into the distance of separation. Distance of separation is given as L. Given as L. So we get Q into L. There is a chance of making mistake by taking Q into 2L. You can take Q into 2L if the distance of separation is 2L. But here it's given distance of separation is L. So if you're substituting that, we get minus of Q into L into E. Minus QLE. That is the answer for this question. It is option C. Another simple question from the first chapter, electric charges and fields, about potential energy of a dipole. Okay, so let me go to the third question now. Two resistors R1 and R2 of 4 ohm and 6 ohm are connected in parallel across a battery. The ratio of power dissipated P1 is to P2. Question from current electricity based on electric power. So let's check the question. There are two resistors R1 and R2. R1 is 4 and R2 is 6 connected in parallel. So if this is the first resistor R1, this is the second resistor R2. They are connected in parallel across a battery. So we can show it like this. This is R1 and this is what? R2. All right. They are asking what is the ratio of power dissipated. Power, there are many formulas, you know that. Electric power, V into I is there. V square by R is there. I square R is there. So which formula we need to use here? How can we understand which formula we can use? For that, you can check the combination. If series combination, current is same. So if current is same, if ratio question comes, you can use the formula I square R, the formula with current. But here this is connected in parallel. In parallel combination, which quantity is same? Voltage is same. So since voltage is same, what we can write? P1 is equal to V square by R, formula means V square by R1. P2 will be what? V square by R2. They are asking what is the ratio? P1 by P2. P1 by P2, which is equal to V square by R1 by V square by R2, which is R2 by what? R1. Isn't it? V square by R1 by V square by R2. V square cancel. So we get R2 by R1. So that's it. What is R2 value? 6. R1 is 4. 6 by 4, which is equal to 3 by 2. So the answer is 3:2, which is option B. Option B is the right answer for this question. Easy, no? If they are connected in series, we need to use I square R formula. So I square R means it is like power is directly proportional to resistance. In such a case, it will be R1 by R2. Here voltage is same. Why? Because they are connected in parallel. So it is R2 by R1. I'll be moving into question number 4. The magnetic dipole moment of a current carrying coil does not depend upon magnetic dipole moment of a current carrying coil. We have a formula in moving charges and magnetism chapter. Magnetic dipole moment M is equal to what? NIA. Do you remember this? NIA. What is N? Number of turns. What is I? Current. What is A? Area. So what are the factors affecting dipole moment? Means number of turns, current and area. Now check number of turns. It depends. Area is there. Current is there. Material of the turns of the coil. Does it depend on the material? Answer is no. So the answer for this question is option D. Option D. When material changes, there won't be any change in the dipole moment unless there is no change in these three quantities. So fourth question is also clear, I think. Question number 5. Kirchhoff's first rule at a junction is in an electrical network deals with the conservation of Kirchhoff's junction rule. We have two important rules by Kirchhoff. One is Kirchhoff junction rule and other is what? Kirchhoff loop rule. Junction rule is current rule, loop rule is voltage rule. In junction rule, which one is conserved? Charge is conserved because it deals with the current. Current is flow of charge. And in voltage rule, which one is conserved? Voltage. Voltage means it is potential. Potential is work. Work is nothing but energy. So please note that in junction rule, which one is conserved means it is charge is conserved. It is law of conservation of charge. But in loop rule, if they are asking loop rule, the answer is energy. But here it is junction rule. So the answer is charge. Charge. Got it? Yes. Question number 6. The conductivity of a metal decreases with the increase in temperature on account of. It's a statement. They are saying that conductivity decreases with the increase in temperature. What is the reason? Decrease in number density, decrease in resistivity, decrease in relaxation time, increase in mean free path. So for this conductivity, what is conductivity? Conductivity is reciprocal of resistivity. Yes or no? Reciprocal of resistivity is called conductivity. We have a formula for resistivity which we derived. Rho is equal to M by N E square into what? 2. This is the formula for what? Resistivity. Then what will be conductivity? Conductivity is sigma. Sigma is 1 by rho. So we get sigma is equal to N E square 2 by M. So this is the formula. Now we can check. First one, decrease in number density. When number density decreases, so the increase, they are asking, the question is the conductivity of a metal decreases with the increase in temperature. When temperature increases, what will happen? When temperature increases, it won't make any change in number density and all. When temperature increases, the only factor that's going to change as per this equation is relaxation time. What is relaxation time? Relaxation time is the time interval between two successive collisions. So when temperature increases, this charge particle starts moving quickly. As a result, the relaxation time will decrease. So it is in the decrease of relaxation time. Here you can see when relaxation time decreases, conductivity also what? Decreases. So when temperature changes, what happens is the factor which is changing with the temperature is what? Relaxation time. So that's an easy question. So please remember this formula. Okay, this derivation is also important, you know that. Now question number 7. Two unequal resistors are connected in series across a battery. Then unequal resistance are connected. Unequal. This is one resistor and this is the other resistor. They are connected across a battery. So this is the situation. This is R1 and this is what? R2. Current, you know that current will be same across both. Potential difference across each resistor is the same? No, never, because potential difference V1 is equal to what? I into R1, V2 will be I into R2. It is given that unequal resistors. So since the resistors are unequal, what about potential? Potential will also be different. So first one is wrong. Current in the smaller resistor is larger? No, in series combination current will be same. Potential difference across the bigger resistor is greater. Potential V is directly proportional to resistance. So if resistance is more, potential will also be more because current is same. So we got the right answer. It's option C. Option C is the right answer for this question. Clear? Yes. Question number 8. A point charge is situated at an axial point of a small electric dipole at a large distance from it. The charge experiences a force F. If the distance of the charge is doubled, the force acting on the charge will become. A point charge is situated at an axial point of a small electric dipole at a large distance from it. If this is a dipole, minus q plus q, axial point means this line at large distance. So here we have a formula for the electric field, which is 1 by 4 pi epsilon naught into 2p by r cube. 2p by r cube. So here the charge experiences a force F. A charge is kept at that point. So if I am taking q as a charge, you know that F is equal to what? That q into E. E values 1 by 4 pi epsilon naught 2p by r cube. If the distance of the charge is doubled, so we need to check how the force varies with the distance only. Distance, how it is related? With r cube, right? Inversely proportional to r cube. Due to a dipole, this is a formula, you know that. It is inversely proportional to r cube. Now the distance is doubled. So new force, F dash is equal to or proportional to 1 by. Distance is double means 2r the whole cube. Right? So we get F dash is proportional to 1 by 2 cube is 8, 8r cube. So 1 by r cube is proportional to F only. So we get new force as what? F by 8. It will become 1 by 8 times. Bit tricky. Don't make mistake. Check the formula correctly. And you know the importance of studying the formula. Alright, so electric field due to a dipole on axial line and on equatorial line, and both are inversely proportional to r cube only. Understood? Yes. Next question, question number 9. If a positive charge is displaced against the electric field in which it was situated, then a positive charge is displaced against. So electric field, assume electric field is directed like this. You know the direction of electric field. It is from positive charge to what? Negative charge. Now it is given that there is a positive charge displaced against the electric field. So you are displacing the positive charge towards left. Then work will be done by the electric field on the charge. No, because if electric field is doing the work, it will push the charge because it will be repelled by the positive charge and attract. It has to go in the other direction. The intensity of electric field decreases. Intensity of electric field, it is uniform, right? Movement of charge won't make any change in the electric field strength. Energy of the system will decrease. It is coming closer to the positive charge, you know. So R is decreasing. The distance between the positive charges is decreasing. So energy will increase. Energy will be provided by external source to displacing charge. That's the right answer, because you just think to move a positive charge towards this, already that positive charge will be experiencing a repulsion by this positive. So we need to overcome that repulsion. To move the charge towards or against the electric field, some external agent should do some work. So external energy should be supplied by the other external agent. Then only we can displace the charge. So energy will be provided by the external source. So here is the answer for that question. Okay, right. I think it's clear. Question number 10. Electric flux emerging out from 1 coulomb charge is very simple question. 1 coulomb charge. Okay, we can directly use Gauss theorem formula. What is Gauss theorem formula? Phi is equal to 1 by epsilon naught into what? Q net. But emerging out from 1 coulomb. So Q net is 1. So we get what? 1 by epsilon naught. Very simple question. Option A is the right answer. Option A is the right answer for this question. Easy? Yes. Question number 11. 11th question. Two capacitors of capacitance C1 and C2 are connected in parallel. If a charge Q is given to the combination, the ratio of the charge on the capacitor C1 to the charge on C2 will be. So this is, what is the situation here? You can check. There are two capacitors. This is C1 and this is C2. C1 and C2. C2. Okay. So it is given a charge what? Q. Q is the total charge given to it. Total charge given to it. So if you are taking charge on this one as Q1 and charge on this one as what? Q2. What they are asking? The ratio of the charge on C1. So we need to find Q1 by Q2. So here you can see capacitors are connected in parallel. In parallel combination, which quantity is the same, is common, it's potential, right? So we can write what? V1 is equal to V2. V1 is equal to V2. What is V1? V1 is equal to, what is the relation between C, V and Q? Q is equal to CV, or V is equal to what? Q by C. So what we can write? Q1 by C1 is equal to what? Q2 by C2. What we need to find? We need to find Q1 by Q2, no? So Q1 by Q2 is equal to what? C1 by C2. C1 by C2. Very simple question. It's option A. Option A is the right answer for this. C1 by C2. Easy. Next, question number 12. The electrical resistance of a conductor varies directly proportional to its area of cross section, decreases with the increase in temperature, decreases with the increase in conductivity, is independent of its shape but depends only on its volume. So let's check one by one. Varies directly proportional to area cross section. You know that R is equal to rho L by A. So how resistance is related to area means it is inversely proportional. So first option is wrong. Decreases with increase in temperature. We already derived a very important idea, expression for the resistivity. So it is inversely proportional relaxation time. That means it is directly proportional to temperature. So when temperature increases, resistivity increases. That means resistance increases. It is given that decreases. So that is also decreases with increase in conductivity. Conductivity is reciprocal of what? Resistivity. So when conductivity increases, surely resistivity decreases. When resistivity decreases, resistance also what? Decreases. So which is our right answer? It's option C. And you can check fourth one, it is independent of the shape. No, it depends on the shape. Resistance depends on the shape. It not only depends on volume. Okay, volume may remain same, but we'll get, hope you remember in stretching a wire and all, volume will be same, but resistance value is changing. Okay, next one, question number 13. Meter square volt raised to -1, second raised to -1 is the SI unit of which of the following? So let's check one by one. Drift velocity. What is the unit? Meter per second. So no need to check it. It's not meter per second. Mobility. Do you remember what is mobility? Mobility is drift velocity per unit electric field. Mobility mu is equal to drift velocity per unit electric field, E. So what is drift velocity unit? Meter per second. Electric field, we have a unit, volt per meter. Yes or no? So we get what? Meter per second into meter by volt. So we get meter square, volt raised to -1, second raised to -1. Got it. So that unit is for which quantity? It is for mobility. Okay, yes. Question number 14. The element of a heater is rated as P, V. If it is connected across a source of voltage V by 2, then the power consumed by it will be. This is a repeating type question. Look at that. What is the meaning of rated P, V? Rated P, V means the power of that device will be P. You will get a power P when you are connecting across a volt V. If you are connecting across a volt V, you will get a power what? P. Then what they are asking is, if you are connecting the same device across a voltage of V by 2, what will be the effective power? So in these kind of question, what we need to do is, we'll start with the given data. Power is P when voltage is what? V. What is the relation between power and voltage? We have a formula. P is equal to what? V square by R. So from this, I can write resistance of that device will be equal to V square by P. Resistance is V square by P. That's a fixed value. Understood? Yes. Now, we are connecting this device across a new voltage. So what is the new power? So I'm going to take that new power as what? P dash. P dash is equal to V square by R again. What voltage is changed? So V dash square by R I am writing. Okay, now what is V dash? V dash is V by 2. It's given V by 2. So squaring we get V square by 4. V square by 4 into what? R. Now R is what? So I'm writing V square by 4 into R is V square by P. R is equal to V square by P. So V square cancel. This P will go up. Look at the result. We are getting what? P by 4. P by 4 is the right answer for this. That is option D. Option D. Be careful, students. Please check the steps. I think it's clear. Okay. Yes. Question number 15 now. A region has a uniform magnetic field in it. A proton enters into the region with velocity making an angle of 45 degree with the direction of the magnetic field. In this region, the proton will move on a path having the shape of a easy question. Based on which topic? Moving charges and magnetism, magnetic Lorentz force. What is Lorentz force? Force on a charge moving particle, right? And we have a formula for Lorentz force. What is it? F is equal to QVB sine theta. This is the formula for what? Magnetic Lorentz force. We have discussed many special cases. Theta 0, force will be 0. Theta 180, force will be 0. Theta 90, force is maximum, QVB, and charge will following a circular path. Theta between 0 and 90. Remember or not? Charge follows a helical path. If this is the velocity direction and this is the magnetic field direction, you can see the particle will be following a path like this. Remember or not? Yes. So what is the answer here? Helical or helix? Helical path is the answer for this question. Got it? Question number 16 now. A charge Q is kept at the center of a circle of radius r. A test charge Q0 is carried from point X to the point Y on the circle such that XY subtends an angle of 60 degree at the center of the circle. The amount of work done in this process will be. Question look like a bit complicated, but this is actually very easy. Very simple question. Listen. Look at this. Let me draw a circle. So this is a circle, and what you can see, where are the points? One is a charge Q is at the center. Here is Q. Okay. X, from X to Y. So X is here, Y is here. This angle is given as what? 60 degree. Here an important point is you would like to move a charge from X to Y, but this point and this point are equidistant from the center charge. That means whatever is the potential at X, the same potential only you will get at what? Y. That means potential at X, V at X is equal to what? V at Y. Or in other words, we can see that this is an equipotential surface. Everywhere the potential is same. What is the work done on an equipotential surface? Work done on an equipotential surface is 0. Remember it or not? Work done on an equipotential surface is 0. So no need of any kind of tension for by seeing these kind of questions. It's very simple. You just use, in most of the question the answer will be 0. You need to check. In most of the question you can see the work done in moving a charge means most of the question will be 0 only. But of course you need to read. There are some other questions also without getting 0. But here it is 0. I hope this is also clear for you. Yes or no? Yes. Next. Question number 17. An isosceles right-angled current-carrying loop PQR is placed in a uniform magnetic field B, pointing along PR. If the magnetic force acting on the arm PQ is F, then the magnetic force which acts on the arm QR will be. So look at this question. Here, the magnetic field is directed along PR. So this is the direction of magnetic field. It's a uniform magnetic field of intensity B. Yes or no? Then the side PR, so this side PR is experiencing a force, side PQ is experiencing a force F. So if you're marking the current direction like this side is experiencing a force F. So what is the force formula? Force on a current carrying conductor. You know that F is equal to ILB sine theta. This is the formula for force on a current carrying wire. So here current is I. Length, let us take the length of PQ as what? L. So then theta is how much? Magnetic field is like this, current is going like this. So theta is 90 degree. So we get F is equal to what? ILB. That's clear now. This is a force on the side PQ. Now what is the question? Magnetic force which acts on the side QR. Then this side will be experiencing how much force? That is the question. Question is clear or not? Now it is given that this is an what type of triangle? Isosceles. So if this is L, this is also what? L. Then what about the length of QR? Root of L square plus L square. We get root 2L. Root 2L. Understood? Yes. That is carrying the same current I. So I'll be writing the new force formula. New force formula will be F dash is equal to I is I, but length is what? Root 2L. Root 2L into B. But here look at the value of theta. What is theta? Angle between that length, current carrying wire, and magnetic field. That means this is a length, this angle. This is what we need. Okay, that's very simple. It's an isosceles triangle, means this angle is 45. This will also be what? 45. So Surely these are parallel lines. This will be what? 45. So ILB into what? Sine 45. So what we get? What is sine 45? 1 by root 2. So we get I into root 2 LB into 1 by root 2. Root 2 cancelled. What is the result? ILB. What is ILB? It is F itself, no? So F dash is equal to F only. There is no change in the force. The force remains as what? F. Clear? Yes. Next question, number 18. An electric dipole consisting of charges plus q and minus q separated by a distance r is kept symmetrically at the center of an imaginary sphere of radius capital R, which is greater than small r. Another point charge q is also kept at the center of the sphere. The net electric flux coming out of the sphere will be. Easy question. Look at this. There is a sphere. And inside the sphere, we are keeping a dipole which consisting of charges plus q and minus q. Plus q and minus q. Not only this, there is another charge, capital Q is kept at the center. What they are asking? Net electric flux. Simple. Gauss theorem. Total flux is 1 by epsilon naught times net charge enclosed. Phi is equal to 1 by epsilon naught times. What's the net charge enclosed? This is plus q, this is minus q, means their net effect will be 0. So net charge is only capital Q. So the answer is capital 1 by epsilon naught into q. That means q by epsilon naught. Q by epsilon naught. This is the answer. Option B is the right answer for this question. Hope it is also clear. Question number 19. A parallel plate capacitor is charged to V volt by a battery. The battery is disconnected and the separation between the plates is halved. The new potential difference across the capacitor will be. This is a tricky one. Be careful while doing this kind of question. You need to understand it clearly. There is a capacitor. Let us take the capacitance as what? C. It's charged to a volt V by a battery. Okay, so there is a battery. Then there will be charge on it. No. How can you find the charge? Q is equal to CV. Q is equal to CV. This is a charge on it. Understood? Yes. Now after that, what they are doing? The battery is disconnected. Battery is disconnected means capacitor is no more a part of the circuit. But whatever charge is already stored in it, that charge will be there as it is. There is no change in the charge. So what is the charge initially? Q. And after that, plate separation is halved. So we are reducing the distance. When plate separation is halved, what will happen to the capacitance? We have a formula. What is capacitance of a parallel plate capacitor? C is equal to epsilon naught A by D. Got it? So plate separation is half. New capacitance C dash is equal to epsilon naught A by half, this means D by 2. So we get what? C dash is equal to 2 into epsilon naught A by D. Epsilon naught A by D. This is what? The new capacitance. And what they are asking? The new potential difference. So V dash, that's what we need to find. V dash is equal to, V is equal to Q by C, no? So we can write Q by what? C dash, which is equal to, Q remains same. Q by, what is C dash? C dash is 2C. Here you can see 2 epsilon naught A by D means 2Z. So we get what? This is equal to Q by 2Z. What is Q by C? What is Q by C? Q by C is equal to V. So we get V by 2. V by 2. Got it. So the new potential is V by 2. It will also be halved. When the distance is halved, you can see potential will also be halved. But don't take this as a general condition. You need to check the, read the question carefully, because if battery is there, and if you are increasing or decreasing the separation, potential will not be affected, because as long as the battery is connected, potential remains same. But here battery is disconnected. That's why potential is changing. Got it? Next, question number 20. N resistors, each of resistances R are connected in series and B in parallel. Each combination is then connected to a source of EMF E. Then the ratio of heat produced per second. Heat produced per second in two cases. Heat produced per second. Heat, rate of heat, that is power only. So ratio of power only they are asking. But what is the situation? Check. In first case, there are N resistors, each of R. So R, etc. N resistors are there. They are connected across a battery. And in second case, the same N resistors are connected in parallel across the same battery. So this is the situation here, a source of connected to a source of EMF E, right? So here voltage is same for both, right? If you are taking the potential difference as V, it is same for both. Now the question is, in first case, what will be the total resistance? R net is equal to, we can write NR, isn't it? This is the total resistance in first case. Second, in parallel, what is the formula? 1 by R net is equal to 1 by R plus 1 by R plus etc. N times. So we get N by R. N by R is 1 by R net. So R net is equal to what? R by N. R by N. We have to find the ratio of power. So P1 by P2. P1 by P2 is equal to, voltage is same now, so we need to use V square by R1 by V square by R2, which is equal to R2 by R1. R2 means in parallel combination, what is the resistance? Which is R by N divided by what? NR. So we get 1 R by N into NR will be R got cancelled, 1 by N square. 1 by N square is the answer, that is 1 is to N square. Option D. Please practice this type of question. I hope this is clear. Question number 21. Two large conducting spheres carrying charges Q1 and Q2 are kept with their centers r distance apart. The magnitude of electrostatic force between them is not exactly 1 by 4 pi epsilon naught Q1 Q2 by R square because these are not point charges. See, what is the situation here? Two spheres, large spheres, okay. Their centers are kept at a distance of r. The problem is if two large spheres are bringing together due to the, if this is positive and this is also positive, due to the mutual interaction between the charges, the charge will be distributed non-uniformly. That means we cannot treat them as point charges concentrated at the center because of the redistribution or non-uniform distribution of what? Charge. That is the answer for this question. So it's a direct one. The answer is because the distribution on the spheres, charge distribution on the spheres is not uniform. If large spheres are taken, this is a problem. Okay, next question, question number 22. A charged particle is placed between the two plates of a charged parallel plate capacitor. It experiences a force F. If one plate is removed, then the force on the other plate will be. This is a tricky question. Listen, there are two plates, right? Two plates. A charged particle is placed between the plates of a charged capacitor, experiences a force F. I'm just considering the charge as Q. It is experiencing a force how much? F. See, you know that we have a formula for the force. F is equal to what? QE. F is equal to Q into, what is the electric field in between the plates of a capacitor formula? It is sigma by epsilon naught, isn't it? So this is a force. When we are keeping a charge in between the plates of a capacitor, this is a force. Yes or no? Now what we are doing, like if one plate is removed, then the force on the particle. If one plate is removed, we can write electric field will change. We can write it as what? QE dash. If only one plate is there, what is the formula for electric field? Do you remember? It is sigma by 2 epsilon naught. Sigma by 2 epsilon naught. So what is sigma? Q into sigma by epsilon naught is F by 2. So F dash is equal to what? F by 2. Simple question. Hope you understood. C, option C is the right answer. It is F by 2. The force will be halved. If one plate is removed, the force will be halved. Got it? Yeah. Next question. Question number 23. A uniform wire of 16 ohm resistance is bent round in the form of a circle. When connected in a circuit between its diametrically opposite points, its effective resistance will be. A uniform wire of 16 ohm resistance is bent in the form of a circle. So total resistance is 16 ohm. It is bent in the form of a circle. When connected in a circuit between its two diametrically opposite. So one point I am taking here, other point I am taking here. So between two diametrically opposite point means like this. Okay, what is the total resistance? It's 16. So this from here to here will be half of that, which is 8. This will also be what? 8. So it is 8, 8 are in parallel. If two identical resistors are connected in parallel, effective resistance will be half of its value. So, or we can use directly parallel combination formula, R1 R2 by R1 plus R2, 8 into 8 by what? 8 plus 8. Okay, so we get the answer as what? Half of this means 4 ohm. 4 ohm is the answer for this question. Very simple one. Don't make mistake. Clear? Yeah. Question number 24. A cell of EMF E and internal resistance R is connected across a variable resistance R. The graph of terminal potential difference V as a function of R is. It's a repeating question. Repeating question. It's actually very easy. Terminal potential difference. Do you remember the formula for terminal P? V is equal to what? E minus IR. So it is equal to E minus. What is I? I equal to E by R plus R into what? R. This is the formula. Now we need a graph. So let's check. They are asking variation of what? Terminal PD with capital R. So let's start with capital R value as 0. If R is equal to 0, if R is equal to 0, tell me what will be the result? E minus R0 means ER by R got cancelled. We get V is equal to E minus E, which is equal to what? 0. When external resistance is 0, terminal PD will be 0. So surely the starting point will be 0. That means option A and option C, leave it. That is not possible because starting point should be what? 0. So it will be either B or D. Then how can you find the which one is correct? For that, I will be taking the maximum possible value. That means if R is equal to infinite, maximum. If R is equal to infinite, what we get? V is equal to E minus E by infinity. By infinity is 0. So what we get? V is equal to what? E. So the maximum possible value of V is what? EMF only. That is when R is equal to infinity. So this is not possible because this graph you can see it keep on increasing, right? So which is the right one? Right answer is this one. It's a repeating question, dear students. So please focus on it. Understood? Yes. Question number 25. A uniform wire of resistance 2R is bent in the form of a circle. The effective resistance between the ends of any diameter of the circle. Already an identical question is discussed. That 16 ohm is bent in a circle. One is 8, other is 8. So here the same way, a uniform wire of resistance 2R. So total is 2R. Diametrically opposite point means this will be R and this will be what? R. The effective resistance between the two ends. Now this R and R are in parallel. So we get what? R by 2. Effective resistance is half of this. R by 2. Simple. Next, question number 26. A current of 10 ampere is flowing from east to west in a long straight wire kept on a horizontal table. The magnetic field developed at a distance 10 centimeter due north on the table is 10 centimeter due north. So let's check. North is here, south is here. Then east, west. Let it be the table. The surface of the table is like this. And what is the direction of current? Current is flowing from east to west. So this is the direction which current is flowing, 10 ampere. It's flowing. Magnetic field developed at a distance 10 centimeter due north. So 10 centimeter due north means here. First let us find the magnitude. What is the formula for magnitude of magnetic field by a straight conductor? Mu naught I by 2 pi R. Substitute, mu naught is 4 pi into 10 power minus 7. Current is given as how many ampere? 10 ampere divided by 2 pi into what is R? It is 10 centimeter. So we can write 10 into 10 power minus 2. So this 10 will be cancelled out. Pi got cancelled. So we get 4 by 2 is 2. This minus 2 will go up. 2 into 10 power minus 5 Tesla. 2 into 10 power minus 5 Tesla is the magnitude. But there are two options with 2 into 10 power minus 5 Tesla. Option A is there. Option B is also there. Now which is correct? Direction. So this is a table surface. You just assume, you can apply right hand thumb rule. If you are assuming this as a table surface, north is on that side. So if you are applying right hand thumb rule, you can see that the closed fingers are going inward. Closed fingers are going in. That means in means if you are taking the surface of a table means in means what? Down. Okay. So it is acting downwards. So option A is the right answer for this. Downwards. Clear? Yes. Question number 27. An electron and a proton are moving along the same direction with the same kinetic energy. They enter a uniform magnetic field acting perpendicular to their velocities. The dependence of radius of their circular their paths on their masses is important question based on Lorentz force. Depends of what? Radius of their path. You know that when a charged particle enters perpendicular to the magnetic field, it follows a circular path, and we have a formula for the radius. R is equal to what? mv by qb. mv by qb. This is a formula, you know that. Okay, but here what they are asking, they are entering a uniform magnetic field with the same kinetic energy. Kinetic energy is same. So how can we make kinetic energy? What is mv? mv is momentum. Do you remember we have a relation in grade 11, kinetic energy and momentum, which is kinetic energy K is equal to P square by 2m. That means momentum P is equal to root of 2m into Ke. This is a relation between kinetic energy and momentum. It's an important relation. Always you should keep it in your mind. Substitute that value for momentum. This is momentum now. So we get R is equal to square root of 2m into Ke by Qb. What is the question? How the radius depends on the mass. It's very simple. Radius is directly proportional to the square root of mass. Radius is directly proportional to the square root of mass, means you can see this is the answer. Option B is the right answer for this question. Clear or not? Question number 27. Okay.
Hi everyone. Let's continue with question number 28. Okay. A charged particle, after being accelerated through a potential difference V, enters in a uniform magnetic field and moves in a circle of radius r. If V is doubled, the radius of the circle will become. Okay, we know when a charged particle enters a magnetic field, uniform magnetic field, it is undergoing a circular path, which means it is going normal to the magnetic field, right? Yes. So we know the equation R is equal to mv divided by qb. This was the equation. And we have some modified form of this equation because the question is talking about potential difference V, correct? Potential difference V. What was the expression for radius of the circular path in which we have accelerating potential is coming up? Like R is equal to mv is going to be the P, right? P divided by qb. Then we have written this is like root of 2 times mass into kinetic energy by qb. And that kinetic energy is replaced by charge into accelerating potential. So we got finally root of 2m q into accelerating potential divided by qb. This was the equation, right? So then what happens if V is doubled? I am not changing any of those other quantities. We just double accelerating potential. See what will be the result. This is the, right now this is the radius of the circular path. What if I change the accelerating potential into 2 times? So what will be the result? The new radius r dash will be equal to, we can say, root of 2mq into 2v, right? The whole divided by qb. That accelerating potential V changes to 2v. It's just doubled. Yes. So look at that. So we have getting an extra term root 2 only, right? Root 2 times, this is nothing but r. So the new radius will be root 2 times its initial value, right? So it's a direct substitution from the equations. Like we have radius of the circular path, 3 different forms of the equation. We have taken the equation which accelerating potential, because the question was talking about accelerating potential. Okay, so option B is the right answer. Okay. Next one. The charge on a body is 8 into 10 raised to minus 12 coulomb. It means that the body has, see the charge, a question from the charging a body, electric charges and fields chapter. So we have 8 into 10 raised to minus 12 coulomb charge. And you have given options, lost electrons, gained electrons, and like this, both options are given, and the magnitude or the number of electrons are different in different options. We know you're given a positive charge, right? A positive charge. If positive charge is given, what happened? When will a body be positively charged? When it loses electrons, right? When it gains electron, it will be negatively charged. So in this case, it can be any one of these 2 options, right? That is what we are going to consider. Option A or option D, because it lost electron, then only it will be positively charged. See, we have Q is equal to N into E. That was the equation. So what is the number of electrons added or removed, lost or gained, is equal to Q divided by 8 into 10 raised to minus 12 divided by what will be the charge of electron, 1.6 into 10 raised to minus 19, right? So 8 by 16, it is going to be 1 by 2, 0.5. We have only one option with 5 into something. So that is option D. Yes, we don't have to waste much time on those questions, right? Yes, so number of electrons lost is going to be 5 into 10 raised to 7 electrons. Okay, now moving on to the next one. A current goes through a series combination of two copper wires of equal length, but their radii are in the ratio 1:2. The ratio of drift velocities of free electrons in the wires will be, question from current electricity, we know drift velocity, right? Concept of drift velocity. See, when you come to drift velocity, we know the equations for drift velocity. Vd is equal to E into E divided by M into relaxation time, where capital E is the electric field in the conductor, E is the charge of electron, M is the mass of electron, tau is the relaxation time. In terms of accelerating potential, we can say it is E V by ml into tau, right? Yes. One more equation we know from the drift velocity and current relation, I is equal to NAE into drift velocity. So mostly the questions will be based on these three equations from drift velocity. Okay, and look, let us go through to this question. You're asked to find out the ratio of drift velocities basically. So VD1 to VD2. What are the given informations? Current flowing through a series combination of two copper wires equal length, but their radii are in the ratio 1:2. Cross-sectional radius is different, right? Cross-sectional radius are different. Cross-sectional radius actually, that is a hint for the area, thickness, right? Thickness are different. A1 and A2 are different. See, and length also, they mentioned length also. Same length, right? They are in the same. So we are going for this particular equation in which we can relate area of cross-section and drift velocity along with the current. Now, if you have two conductors connected in series, see, these are the two conductors connected in series. Fine. Whenever they are connected in series, we know they will have the same current. Current I will be same for both of them. So we can say I1, see, I1 is going to be N1, A1, E into VD1. E is a charge of electron, so that will be a constant for, like in that equation. So what will be current in the second conductor I2? That's supposed to be N2, A2, E into VD2. See, I wrote I1 and I2 to represent current in 1 and 2. But I told you, since it is a series combination, both of them will have the same current. I1 is equal to I2. Okay, so I am going to take the ratio. Yes, and one more thing, see, look at this. Instead of A1 and A2, I am going to write the cross-sectional area. Cross-sectional area of the wire is going to be pi R1 square, right? Pi R1 square. And that of the second wire will be pi R2 square. See, this is the equation relating current and drift velocity. Now I told you I1 is equal to I because, I2 because they are connected in series. Same current will flow through them. If you take the ratio I1 by I2, what will you get? I1 by I2 is equal to, that is going to be 1 only, right? Because I1 is equal to I2. Okay, then N1 and N2, look at that. Both of them are copper wires. Both of them are copper wires. If they are made of same material, their number density N1 and N2 remains the same, right? What is N1 and N2? Number of free electrons per unit volume. That is constant for a given material. So N1 and N2 will be the same. Yes. And pi gets cancelled obviously. R1 by R2. R1 by R2 ratio is given 1:2. So we can say it is 1 by 2 the whole square. R1 by R2 the whole square. Correct? Yes. R1 square by R2 square. EE gets cancelled and we get VD1 divided by VD2. Yes. And we need the ratio VD1 by VD2. That is your final answer. So you can just rearrange this. N1 and N2, I told you, they cancel each other because they are made of same material. Yes, I1 and I2 is equal to 1. So we can say VD1 by VD2 is equal to just 4 divided by 1, right? 4 divided by 1. And what is the ratio? You have given option B as 4. 4:1, right? So option B is the correct answer. Okay, so the question was related to the equation that connecting relation between current and drift velocity. You are given two conductors connected in series. Since it is series, current will be the same. Okay, so we equated the current in both the conductors. We had N1 and N2 cancelled because they are made of same material. E will be same in both the cases. That also will be cancelled. Pi will be cancelled. Radius ratio was given in the question. Using that, we found out VD1 to VD2 ratio. Okay, fine. Then 31. A charged particle at rest is subjected to an external magnetic field B. If no other force act on the particle, then it will. See, be very careful. Be very careful. We have a charged particle at rest. First of all, it is a charged particle Q. Yes, it is at rest. Now, what do you have? We have an external magnetic field. Let me apply an external magnetic field in this case. See, we have an external magnetic field present in this region. This is magnetic field B, uniform magnetic field, suppose. That is a given situation. And remember, this charge is at rest. So the questions, if no other force acting on the charge, remember, then what will be the correct option? Option A says accelerates. The charge will accelerate along the direction of the magnetic field. B says the charge remains at rest. Option C says it moves in a circular path. And option D says move with a constant speed along the direction of B. And the correct answer is, what's the correct answer? The charge remains at rest. Yes. So why the charge remains at rest? Because the charge was initially at rest. If it has to start moving, there should be some force acting on it, right? There should be some non-zero force acting on it. The question says there is no force acting on the body right now other than the presence of a magnetic field. We know whenever the charge passes through a magnetic field, that charge experiences a force F is equal to QVB sine theta. But this is only for what kind of charges? Moving charges. The charge should pass through the medium, the magnetic field. If it remains at rest, if the charge was at rest, what is the velocity of the charge? Velocity of the charge is 0. Correct? This is the only force we expect, right? When the charge and related to magnetic field, we have only one force, which is F is equal to QVB sine theta. But this force is only for what? For the moving charges. Okay? Charge should move. If V is equal to 0, if the charge is at rest, no force acting on it. So the charge remains at rest. Okay, I hope it is clear. Moving on to question number 32. A current carrying loop is placed in a uniform magnetic field. The torque acting on it does not depend on. See, you are given 4 options here. Out of these 4, like the torque acting on the loop does not depend. Very simple. If you go through the equation, what was the expression for torque acting on a loop of wire? Torque is equal to, we know, the mb sine theta, right? Where m is the magnetic dipole moment, which we know it is I into A, right? That is a magnetic dipole moment into b sine theta, right? So that is the equation. If you have n number of turns, there will be n also, nia sine theta, nia b sine theta. That is a torque equation. Now check the options given. See, magnetic field. Yes, magnetic field has a role in it, right? See, magnetic field B is there in the equation. Yes. So it is not the option. Current in the loop. I has, it depends, torque depends on current. Then area of the loop. See, area of the loop. A stands for area of the loop only. And shape of the loop. See, that is the correct answer for the question, right? So that torque acting on the loop is independent of the shape of the loop. Depends only on the area enclosed by that particular loop. Whether it is square or circular or rectangular or irregular shaped loop, it doesn't matter. Area is only to be substituted. Shape doesn't matter, okay? So option D is the correct answer for question number 32. Then question number 33. 2 identical coils carrying equal current are held concentric with their planes perpendicular to each other. The ratio of magnitude of magnetic field at the center of the coil to that of the resultant magnetic field at the center. See, we have to find out magnetic field ratio of 2 different magnetic fields. What are these 2 magnetic fields? 2 identical coils carrying equal current are kept in the concentric with their planes perpendicular to each other. We have 2 loops, right? One of the loops may be like this and the other loop is going to be like this, okay? mutually perpendicular planes. Yes. And the ratio of magnitude of the magnetic field at the center of one of the coil to that of the resultant. See, we know they are identical loops. Identical loops. We know what is the magnetic field B at the center of a loop. Magnetic field at the center of a loop. Application of Biot-Savart law, right? We had an equation. B is equal to mu naught I by 2A. Correct? If you have only one single turn, it is mu naught I by 2A. If you have n number of turns, mu naught Ni by 2A. That is the expression for magnetic field at the center. We have two loops. Both the loops are identical. Identical in the sense their radii remains the same. Both of them have same radius. A remains the same. A is the radius of the loop. Both of them carry same current also, which means both the magnetic fields B1 and B2 are equal by magnitude, right? Mu naught I by 2A. Two identical loops. They are kept in mutually perpendicular planes. Okay. See, we know according to the right hand thumb rule, magnetic field due to one of the loop is going to be vertically upward, and if the other one carry a current like this, so then magnetic field due to that loop will be in this direction. So this is B1 and B2. See, we have discussed similar kind of questions in the class. Yes, so B1 and B2. What about the angle between B1 and B2? 90 degree. Yes, 90 degree. So this angle is 90 degree. How will you find the resultant? Resultant of two magnetic fields BR is going to be equal to root of B1 square plus B2 square plus 2B1 B2 cos theta. Here it is cos 90. That term will be 0. Not only that, we know B1 and B2 are equal by magnitude. B1 is equal to B2. Theta is equal to 90 degree. That is what we have to apply here. Then what will you get? Resultant is going to be equal to just B1 is equal to B2 is equal to B. That is what I am going for. B is one of the magnetic fields, right? B1 and B2 are equal by magnitude. So one of the magnetic field is B. Yes. So what will be BR? In terms of B, it will be just B square plus B square. So what will you get? The rest of it will be 0, right? Root of, like 2B1, B2 cos 90 will be completely 0 as cos 90 is 0. So we get root 2 times B. Got it? Root 2 times B. So magnetic field at the center due to one of the field, one of that particular loop is B. Magnetic field due to the both of them, the resultant is going to be root 2 times B. What was the question? The question is magnitude of magnetic field at the center of one of the coil. Yes, at the center of one of the coil, which is B, divided by to that of the resultant magnetic field at the center. Resultant magnetic field at the center is what? BR. Correct? Yes. So what is it? B divided by, what is your resultant magnetic field? Root 2 times B. So B and B gets cancelled. What is the correct answer? 1 by root 2. Option A is the correct answer, right? Yes. So we calculated magnetic field at the center due to two concentric circular loops. That is root 2B. Because they were identical loops, same current flowing through them. So we got root 2 times B. Where B is magnetic field due to one of them. Yes. So we are asked to find the ratio magnetic field due to one of them to the resultant, B by BR, which is easily 1 by root 2. Okay? Yes. So option A was the correct answer. Fine. Moving on to the next question. See, an electron is revolving around a nucleus in a circular orbit of radius r with a constant speed v. Good. The magnetic moment associated with the circulating current is. See, this we derived in the class, this question. Those who remember the equation, by the time they must have found out the correct option, right? It is option D, half EVR. That is how we get it. Magnetic moment associated with the electron. Yes, because the current due to the motion of electron in this loop. See, if this is a radius of an orbit of an electron and the electron revolves in this orbit, we can find out current I as charge by time. Correct? What was the charge? Charge is charge of electron. One electron is revolving in that circular orbit. So charge is charge of electron divided by what is time taken to complete one revolution. That is called the time period T, right? Which can be calculated as E divided by time period of revolution is going to be If radius of the circular path is r, time period is going to be total distance by speed. Total distance in one revolution is 2 pi r divided by v is going to be up, like EV. So basically current I is equal to EV divided by 2 pi r. I hope it is clear. That is a current. And what about the area? Area of this loop, if r is the radius, area will be pi r square. Now we know how to find out magnetic moment of a circular loop. Magnetic moment of a loop is going to be, magnetic moment M is going to be current into area, IA. We have only one single turn. If you have more turns, it will be N times IA. So this is I into A. What is I? EV divided by 2 pi R into, what is the area of the loop? Pi R square. So we can cancel these terms here. One of the R gets cancelled, pi gets cancelled. We get EVR divided by 2. That was the option I told you right in the beginning, right? So magnetic moment associated with a revolving electron in an orbit is going to be EVR by 2, where V is the speed of revolution, R is radius of the orbit. Okay, so question number 34, option D is the correct answer. Next one, 35. An electric dipole of length 2 centimeter placed at an angle 30 degree with the electric field 2 into 10 raised to 5 Newton per Coulomb. If the dipole experiences a torque of 8 into 10 raised to minus 3 Newton meter, the magnitude of either charge of the dipole. Again, a straight direct substitution only. We know what is the expression for torque acting on a dipole. Tau is equal to, what is the torque? Is going to be like mb sine theta, right? mb sine theta. Right, sorry, this is electric dipole. See, in between magnetic dipole is also coming. Electric dipole is going to be P E sine theta, right? That is the torque acting on it. Where P is the electric dipole moment, so we get 2A into Q, where 2A is the distance, Q is magnitude of one of the charges, right? But magnitude of the charges, that is P. P is equal to 2A into Q. Into electric field E into sine angle is given as 30 degree. You are given even torque also. Torque value is given. The only unknown quantity here is Q, right? Because E is given as, what is your E? E is 2 into 10 raised to 5 Newton per Coulomb is given. And length of the dipole 2A is given as 2 centimeters, 2 into 10 raised to minus 2. And theta is given as sine 30, I told you already. And torque value is 8 into 10 raised to minus 3 Newton meter. So we have all the values. So let us substitute. 8 into 10 raised to minus 3 is the torque. Okay, is equal to 2 centimeters, 2 into 10 raised to minus 2 into Q is to be calculated. That's the only unknown term. Into electric field is given as 2 into 10 raised to 5 into sine 30 is going to be 1 by 2. Yes, so we can cancel these terms, right? Then we can cancel this by 4. So nothing is here, just a 10 raised to 5 and 10 raised to minus 2. So we can write Q into 10 raised to 3, and what is here? 4 into 10 raised to minus 3. Therefore, what is Q? Q is 4 into 10 raised to minus 3 divided by one more 10 raised to 3, that comes up 10 raised to minus 6. 10 raised to minus 6 is going to be 4 microcoulomb, right? 4 microcoulomb is option A. That was easy, just direct substitution only. We are given all the values except Q. So it was easy for us. If you know if you remember the equation, very easily we can find it out. Yes. Yes. Let's move on to the next question. Question number 36. Two horizontal thin long parallel wires separated by a distance r carry a current I each in the opposite direction. The net magnetic field at a point midway between them will be. Okay, see, here we have a problem here. This question, either we have to change this opposite into the same direction, then only one of the matching option is available. If you go for opposite direction, none of these options are matching. So let us try with current flowing in the same direction. Okay, yes, so note the change. Now, two horizontal parallel conducting wires. We know whenever we have a current carrying wire, it produces a magnetic field around it, right? The current I is flowing through it. Yes, this is the first conductor. And we have one more conductor parallel to it at a distance r as per the question. You're given the perpendicular distance is r. So this distance is given as r. Fine. Now, you're asked to find total magnetic field at the midpoint, like half the way with the total distance. See, I told you current is changed from opposite to the same directions. So now both currents are flowing in the same direction. We know both of them will produce magnetic field at that particular point. Yes, what will be magnetic field due to the green conductor at the midpoint? Suppose this is the midpoint. What will be the magnetic field due to the green conductor? The green conductor, according to the right hand thumb rule, magnetic field due to that green conductor is a cross, right? At this point, it's a cross. That is into. Distance from the wire, we have to take that distance as r by 2. Yes. So let us find out magnetic field B1. What is the magnetic field due to the first conductor? B1 is going to be mu naught I by 2 pi into the distance, right? 2 pi r, that is the equation. Mu naught I by 2 pi r is the equation for magnetic field due to a long straight conductor. Yes, so the distance is actually r by 2, right? R by 2. So from the wire to the point, to the midpoint is r by 2. So these 2 and 2 gets cancelled. We get mu naught I divided by just pi into r. And it is a cross. I told you it is into the plane, right? Into the plane at the point. Then what about the magnetic field due to the second conductor? See, second conductor also carry a current. See, magnetic field due to the second conductor also can be found out using right hand thumb rule. So according to that, the magnetic field is a cross on the right side, but a dot on the other side, right? You know, left side of the yellow conductor is a dot. So magnetic field due to the green conductor is a cross, due to yellow conductor it is a dot. They are in the mutually opposite direction. Let us find out magnitude of B2. B2 is going to be mu naught into same current and same distance also, right? 2 pi r by 2, because this distance also will be what? Half of the total distance. We are going for the midpoint. Good. So we get the same magnitude mu naught I divided by pi r, right? It is a cross, you know, this is a dot. First one was a cross, the second one is a dot. So what do you think about the total field? Two equal magnetic field acting in the opposite direction. See, B1 and B2 are equal and they are in the opposite direction. So they cancel each other, and what is the total magnetic field at the midpoint? It is 0. Option A. Okay. Yes. So that is why I told you, if it was not in the same direction, if the current were in the opposite directions, then what will be the result? See, if the current is flowing in the other way around, the magnetic field from the dot, it will be a cross only. I am talking about the yellow conductor, okay? Yellow conductor will also produce what? One cross. So these two should be added up instead of subtracting, because they are in the same direction now. I am talking about if the current were in opposite direction, okay? When you try this, you won't get any matching option here. That is why we considered current in the same direction, okay? Yes, so note the change in question number 36. Now, moving on to the next question, question number 37. A charge Q is placed at the center of the cube. Right, we have a cube and a charge is kept at the center, capital Q. The electric flux through one of its phases. We know this question. See, a question based on the Gauss's theorem. If you keep charge at the center of a cube, we know total flux across the cube can easily be calculated. Total flux according to Gauss's theorem, it is going to be Q enclosed by epsilon 0. So that is going to be capital Q by epsilon 0, because total charge enclosed by the cube is capital Q only, right? So we can say phi total flux across the cube is going to be Q by epsilon 0. But the question is not about total flux. We know it is through one of its surfaces. We have 6 phases for the cube. Since the charge is kept exactly at the center of the cube, each phase will get equal flux, right? So flux across one of the phase, right? Across one phase is going to be equal to 1 by 6th of total flux. 1 by 6th of the total, because we have 6 phases and flux will be divided equally. So 1 by 6th of the total flux is going to be what? Like phi is going to be Q enclosed by 6 epsilon 0 should be the answer. 1 by 6th of total flux. So option B is the correct answer. That was an easy question, we know. Question number 37, option B. Now, moving on to the next one, 38. Capacitors each of 4 microfarad are to be connected in such a way that the effective capacitance of the combination is 6 microfarad. Yes, 6 microfarad should be the effective. You can connect like 4 microfarad capacitors. How will you get this by combining them? We have to get. So let us check the options, that is better. See, all three in parallel. When capacitors are connected in parallel, we know equivalent capacitance is the sum of the capacitors. So it will be 4 plus, see, 3 capacitors in parallel, 4 plus 4 plus 4 is going to be 12, right? Microfarad, that is not the option. No, that is not possible. We need 6 only. Then all in series. Next one is all in series. We know identical capacitors in series. C equivalent of identical capacitors in series is going to be C by N. Correct? If you connect 4 of them in series, we get, 3 of them in series, it is going to be 4 divided by 3 microfarad. That is also not true because we are looking for 6 microfarad as a combination. Now, either of these two can be the answers, right? Let us check the third one, option C. 2 of them are connected in series and the combination is in parallel to the third. So, they say combination of 2 in series, then that should be connected to the third capacitor in parallel. So, these two are 4 microfarad each, right? So, what will be the effective of 1 and 2? 1 and 2 effective capacitance is going to be like identical capacitors, 4 microfarad each, 4 by 2, that will be 2, right? 2 microfarad. And in the other branch, we have one more 4 microfarad capacitor. Yes, now look at that. 4 and 2 are in parallel. We know the total is 6 microfarad. So, which combination is correct? Connecting 2 of them in series to that combination, third one is connected in parallel. Yes, so option C is the correct answer. Okay, yes. Question number 39, 39th one. Yes, two long parallel wires kept 2 meters apart carry 3 ampere current each in the same direction. The force per unit length on the wire due to the other is. We know force between parallel conductors, right? Parallel conductors. So, if there are 2 conductors parallel to each other, the force between them, what was the equation? If the perpendicular distance between the 2 parallel conductors is R, each of them carry current I1 and I2, right? Then we know the equation for the force, F is equal to mu naught I1 I2 divided by 2 pi R into L, right? L is the total length of the that particular conductor. Then you will get total force acting on the conductor. Here you are asked to find out force per unit length. Force per unit length. So it is F by L, which is this much only, right? Mu naught I1 I2 by 2 pi R. Okay, one more thing. 2 currents are in the same direction, right? So currents are given in the same direction. What about the same current? If current flows in the same direction, we know the force will be attractive. Correct? Force will be attractive. So we have to find out an attractive force. Look at the options. We have 2 attractive forces and 2 repulsive forces also. Okay. So then let us check which option will be correct. So force supposed to be attractive because we know same current. Current in the same direction will attract, the conductors will be attracting towards each other. Now let us check the magnitude. We have force per unit length, F by L is equal to mu naught is going to be 4 pi into 10 raised to minus 7 into I1 into I2. Both of them carry equal current, 3 amperes each, divided by 2 pi into what is the distance between the 2 wires? R value, long parallel wires kept 2 meters apart. So distance R is given as 2 meters. All values were given, just direct substitution only. So we get 4 pi and 2 pi gets cancelled by 2. This 2 and 2 gets cancelled, right? Yes. So what is the remaining value? 9 into 10 raised to minus 7, and the force supposed to be attractive. Okay. So 9 into 10 raised to minus 7, the force supposed to be attractive. Look at this. 9 into 10 raised to minus 7, it should be attractive. This option is supposed to be correct if the option given as attractive. Okay. So then option C is correct because this one is also attractive. But look at the power is different, right? So like that value is wrong. So you can just change this. This is the correct option. Option C. Okay, so it was direct substitution only. We had all the values given in the question. Just substitute and simplified. And you have to identify what should be nature of the force, attractive or repulsive. Since current is given in the same direction, same current attract, opposite current repel, right? We know. Okay, moving on to the next one. Question number 40. A battery of EMF E and internal resistance R is connected to an external circuit. question from the cell. Yes, the potential drop within the battery is proportional to. See, we are talking about potential drop within the battery, inside the battery, right? We know whenever we consider a battery, it offers some small resistance to the flow of current. That resistance is called internal resistance of the cell, correct? Internal resistance. Whenever this cell is used in a circuit, there will be some current flowing through that internal resistance, which will cause some potential drop inside the cell. That potential drop is current into resistance R. We are talking about that particular potential drop inside the cell. See, what are the given options, like which is proportional to? Potential drop inside the cell is proportional to. One is the internal resistance and the other quantity is what? Electric current flowing through the cell, right? Yes, so look at that. The only possible answer will be current in the circuit. There is no mention about internal resistance of the cell. So option A should be correct answer. Okay, yes. Question number 41. Yeah. The question is about two wires of equal length and radii R and 2R are connected in series. Okay, their resistivities are 2 rho and rho respectively. For the same current passing through the combination, the potential drop across their ends will be in the ratio of. You are asked to find out potential drop across a given wire. We know whenever we have a conductor given and that conductor offers a resistance R, right, to the flow of current, if there is a current I flowing through it, yes, the potential difference across the resistor or across the conductor, across the ends of the conductor AB, V is equal to, potential drop V is equal to the product of current and resistance, right? V is equal to IR, always. Yes, current flowing from A to B, that means A is at higher potential, B is at lower potential. Electric current always flows from high potential to low potential. Yes, and then potential difference between A and B, there is a potential difference, right? High, low. There is a potential difference. That potential difference would be V is equal to I into R. This is what we know. You are given two conductors in this question. Conductor 1, right? It has some, both of them have same length, but radii are different. Radii of cross section, are different. So this is the first conductor, and the second conductor may be a more thicker one. See, these are the two conductors connected. They are connected in series, same length also given. Yes, we know one important point, whenever they are connected in series, we can expect same current flowing through them. There is no branching of circuit, the same current will be flowing through both the conductors, I. Right. So there will be a potential drop V1 across the first conductor, and there will be another potential drop V2 in the second conductor. You are actually asked to find out what is V1 by V2, that's it. V1 by V2. Potential drop across their ends will be in the ratio of. So what about the potential difference across the ends of the given conductor, which is I into R, right? So we can say this is I1 R1. For the first one it is I1 R1, second one is going to be I2 R2, but we know since they are connected in series, see, series combination, they are connected in series, I1 and I2 will be equal. So I1 and I2 gets cancelled, we will get the ratio as R1 by R2. So we have to find out V1 by V2, which is actually the ratio R1 by R2. Now, what will be R1 by R2? R1 is going to be rho 1 L1 by A1 divided by rho 2 L2 by A2, because resistance is resistivity times L by A, right? You are given resistivity and radius ratio. And one more thing is given in the question, they are equal length. Both conductors are of equal length. So L1 and L2 gets cancelled there itself. So what about this ratio now? This ratio could be rho 1 by rho 2, yes. And 1 by A1 by 1 by A2, which is going to be into A2 by A1. But that A could be, what is that A value? A is going to be pi R square, right? So pi R2 square divided by pi R1 square. Pi and pi gets cancelled. So finally, V1 by V2 is going to be equal to rho 1 by rho 2, okay, into R2 by R1 the whole square, right? R2 by R1 the whole square. If you substitute those ratio given, you will get the final answer. So rho 1 by rho 2. Rho 1 is 2 rho, rho 2 is rho only. Yes. So we get 2 rho divided by rho, that is R1, rho 1 by rho 2. Then R1 and R2 is going to be, see the ratio is other way around, R2 by R1, right? So it is 2R divided by R the whole square. So what will we get? We get 2 rho and rho gets cancelled, right? First ratio is only 2/3. R square gets cancelled. 2 into 2 square, that is going to be 8. 8:1 supposed to be the ratio, and that is our option D. Okay, so we need only the basic concept, how to find out potential drop across a given conductor. V is equal to IR. Yes. How can we write R resistance in terms of rho L and A? That also we used. Then we have taken the ratio, we got the correct answer. Okay, fine. Question number 42. About combination of cells, right? Two cells of EMF E each and internal resistances R and 2R are connected in parallel combination of two cells. We know the equation for equivalent EMF. E equivalent is equal to E2 into R1 plus E1 into R2 divided by R1 plus R2. That is the equation for equivalent EMF, right? E equivalent, E2, EMF of second cell, R1 that of the first internal resistance. See, E2 and R1, right? E1 and R2, that is how we got the equation. So we are given all the values, you are asked to find out what is equivalent EMF of the combination. Just substitute the values, that's it. See, what is E2? E2 is a second cell, that is both of them have same EMF only. So E into, what is R1? Resistance of the internal resistance of the first cell, just R only. Then E1 is again E, because both of them are E only. But internal resistance of second one is different, it is 2R into 2R. Good. Divided by R1 plus R2 is going to be R plus 2R. And look at this, E into 2R, that is 2ER plus one more ER, that becomes 3ER, divided by, in the denominator we get 3R. So 3R gets cancelled from the numerator and denominator, we get just simply E. And E is the one of the options given, option D. Okay, here also it is direct substitution only. We have to just remember this equation for two cells connected parallel to each other. Okay, wait. And one important point you have to remember here, see, this is positive terminal, this is negative terminal. See, that is one possible mistake when you do this. When the cells are parallel combination, it's supposed to be given positive terminal should be connected to the positive of the next, right? That is how it should be connected. Positive of the cell E1 should be connected to positive of the cell E2. Then only we have this equation. But look at the combination given. If the combination given, positive terminal is connected to the negative of the second. These are called reversed cells, right? Reversed cells. If they are reversed cells, instead of plus, what should be the sign? Instead of plus, it should be minus, right? Minus. So that is what we have to do here. There will be a minus sign here. So ER minus 2ER is going to be just ER only. ER divided by ER minus 2ER is going to be just ER minus 2ER is going to be like ER only divided by 3R. Now RR gets cancelled. Your answer is changed to what? E by 3. Okay, so be very careful. If you're given a diagram, see, nothing mentioned, no mention about reversed cells in the question. That you have to identify from the given diagram. So instead of D, what should be your answer? It should be C. See, both matching options they have given to confuse us. Yes. Okay. So this was a reversed cell. That is why plus changes to minus. Okay. So here we expect a minus sign here in the calculation. That is neglected because if you take this as E2, this as E1, that problem will be solved. So we take the magnitude only. Okay. Fine. So question number 42, option C. Now, question number 43. In a moving coil galvanometer, the deflecting torque tau acting on the coil is related to the current I flowing through it as the relation between torque and current in a loop of wire in an external magnetic field. We know the equation. Torque is given by, what is the expression for torque? I mb sine theta, right? mb sine theta. That was the equation where m is the magnetic dipole moment. Yes. So magnetic dipole moment is written as I into A into B sine theta. This was the equation. correct? If you have n number of turns in the loop, there will be n also, n times I, A, B sine theta. See, for a given loop of wire, number of turns remains the same, area of the loops remains the same, right? And B, what is B? External magnetic field, that also remains the same. And here theta is always 90. We know in a moving coil galvanometer, radial magnetic field is available. So theta is taken as 90 in all orientations. So torque is proportional to what? The current, I. So the relation is torque is proportional to I only. Correct? Option C. That was a direct question. 44. The EMF and internal resistance of the cell are E and R, small r respectively. It is connected across an external resistance, R is equal to 2 times R. It means 2 times internal resistance, because internal resistance was just R before. Potential drop across the terminals of the cell. We know terminal potential difference of a cell can be calculated as its EMF minus current into internal resistance. See, we have to find out this V only. E is given already. Internal resistance is R only. The only unknown term in this equation is what? I, the current. Okay, so if you can find out current in this one, then you can substitute that here, you will get the final answer for terminal potential difference. Okay, in a circuit, how will you find the current? What was the equation for current? Total current in a circuit, when a cell of internal resistance small r is connected to an external resistance capital R. See, the circuit was, this is a cell, that cell has an internal resistance, it is connected to an external resistance capital R. This is internal resistance, this is E. So there is a current expected in the circuit, right? That current I can be calculated as, see, EMF of the cell divided by the total resistance of the circuit, R plus R, right? That is what we know. EMF divided by total resistance. Total resistance in the sense, internal resistance of the cell and external resistance you connected in the circuit. Yes. You are given external resistance is 2 times internal resistance. So we can say E divided by 2R plus R. So we get I is equal to E divided by what? 3R. That is the expression for current. Now it is ready to substitute in your equation here. E minus, what is I? E by 3R. E by 3R into 1R also there, because it is I into R. So R gets cancelled. What will you get? E minus E by 3. So 3E minus E is going to be 2E. 2E divided by 3 is the correct answer, right? 2E divided by 3 is one of the given option, which was C. Okay, so basic question only, right? There is no twist, nothing is given. Like, you know, most of the information was given in the question. We have to just substitute and simplify. Okay, question number 45. The magnitude of electric field due to a point charge, all the way to electrostatics once again. Electric field, object at a charge, point charge object at a distance of 4 meter is 9 Newton per coulomb. Electric field strength is given 9 Newton per coulomb. Where is it? 4 meters away from a point charge. Yes. From the same charged object, electric field of magnitude 16 Newton per coulomb will be at a distance of. Okay, so we have to find out electric field, the distance from the charge where electric field strength is what? 16 Newton per coulomb. But you are not given the source charge. If you are given the source charge, we know E is equal to KQ divided by R square was the equation. You are asked to find out what is R, right, or R square. Then you are given E value. If you know Q, you can easily, you could have find out easily that particular R value. But Q is not given. So from the given two situations, we are going to find out that particular R. See, electric field strength was 9 Newton per coulomb before. Now the new point, it is 16 Newton per coulomb. So definitely we have come closer the charge, right? Because electric field strength is now more from 9 to 16. Okay, so we are expecting a result which is less than 4 meters. Yes, let's see. So in the first case, we get electric field E. See, in this part, this is a K is a constant. Q is also same in both the cases. We are going for the same point source charge. See, we have a source charge Q. This is one point, this is the other point. So same Q, right? In one point it was 9. Newton per coulomb. In the other point, it is 16 Newton per coulomb. So Q is also same for both. So we can say E is proportional to 1 by R square, correct? Because K and Q are the same in both the cases. So we can say E1 is proportional to 1 by R1 square. E2 is proportional to 1 by R2 square. If you take the ratio of these two, we get E1 by E2 is equal to R1 by R2 the other way around, R2 square by R1 square. Correct? Because 1 by R1 square by 1 by R2 square. See, E1 and R1 are given. E2 is also given, you have to find out R2, correct? Substitute the values now. E1, first value was 9, divided by second electric field strength is given as 16, is equal to R2 we don't know, R2 square is to be calculated. R1 is given, what is it? 4 meters. So it is going to be 4 square. See, that's a beautiful ratio. All of them are perfect squares, right? Take a square root on either side. So what will you get? 3 divided by 4, correct? 3 divided by 4. RHS is going to be R2 divided by 4 square. Square root is going to be 4 only. So that 4 and 4 gets cancelled. What is R2? R2 is equal to 3 meters, right? Directly we got R2 is equal to 3 meters. That was one of the given option. Option C once again. Okay, so electric field as we expected, we came closer. Before it was 4 meters, now it is only 3 meters. Okay, fine. Moving on to the next. A point P lies at a distance x from the midpoint of an electric dipole. Okay, electric dipole on its axis, on the axial line. Right. The electric potential at a point P proportional to. See, you are asked to find out potential. Not to find out potential, what will be that potential proportional to what power of distance. That is what we have to identify. If you know the equation for potential, this can be solved within seconds, right? What is expression for potential due to a dipole? V is equal to K into P cos theta divided by R square. Correct? That is the expression for the potential. Since it is on the axis, if it is axis, we know that theta will be 0, cos theta will be 1. So we can say K is a constant, dipole moment P. If you go from point to point, dipole moment will not change. That is one given dipole only. R is the distance. We can say V is inversely proportional to R square. So V is inversely proportional to, instead of R, the distance is given as X. So proportional to what? X square only. That is option 1A. Okay. Yeah. So that is direct question only. If you know the equation, we can find out the relation between V and R easily. Okay. Question number 47. Again, a cell question. A cell of EMF E is connected across an external resistance R. Yeah. A similar question we have done before. When current I is drawn from the cell, the potential difference across the electrodes of the cell is drops to V. So you are given both terminal potential difference and also what? EMF of the cell. External resistance used in the circuit is R. See, all of them are standard notations only. Right. The internal resistance R of the cell, that is to be calculated, right? Yes, we know. We derived this equation in the class. So if you remember the equation straight, you can go to the options, mark the correct option and keep going. See, we have expression for terminal potential difference is E minus I into R, where R is the internal resistance. That internal resistance to be calculated, so IR is going to be E minus V. We just transpose the equation. R is equal to E minus V divided by I. We don't have such an option here. In all the options, we have capital R, external resistance. And I is only in one option, right? Yes. But there also we have an external resistance R connected given. So I we have to replace somehow. We know terminal potential difference of the cell can also be calculated as current flowing through the circuit into the resistance, external resistance connected, right? The external resistance connected R. V is equal to IR. Therefore, I is equal to V divided by R. If you substitute that here, you will get the answer in the next step. See, E minus V divided by I is going to be V divided by R. That R comes up. So what is our equation? R is equal to E minus V divided by V into R. That was one of the given option D. Right? Internal resistance of a cell can be calculated using this equation. Okay, we simplified this equation further, right? So E by V minus 1 into R. That is how we wrote it. Yeah. So this form is given. That is the correct answer. 48. Next question. Beams of electrons and protons move parallel to each other in the same direction. They, options, attract each other, repel each other, neither attract nor repel. Force of attraction or repulsion depends upon speed of the beams. See, the question is based on two parallel current carrying conductors, right? Whenever charges flow in a given direction, suppose protons, a beam of protons are moving. Suppose protons are moving in this direction. And electrons are also moving in the same direction. That is what the question says. So if you have a beam of electrons which are moving in the same direction parallel to this, these are the two parallel current carrying conductors. Flow of charges can be considered as current. Yes. See, the difference in this case is like if protons are moving in the downward direction, current also will be in the same direction, I. But what about electrons? Since they move in the downward direction, what about the conventional current? Opposite to the flow of electrons, right? Yes, so current is opposite direction. We know same current attract, opposite current repel, right? So since we have opposite current, what happens? There will be a repulsive force. So they repel each other. Two parallel current carrying conductors, same current, if they flow current in the same direction, attracts each other, same current attract, opposite current repel. Yes, so there is a repulsive force. Okay, fine. 49. A long straight wire of radius A carries a steady current I. The current is uniformly distributed across its area of cross section. The ratio of magnitude of magnetic field B1 at A by 2 and B2 at a distance 2A is. Okay, so this question is about from the current carrying, long straight current carrying conductors. We know what is the expression for magnetic field due to a current carrying conductor at a distance R from the wire. If I is the current flowing through the conductor, R is the distance, then we can say magnetic field B is equal to mu naught I divided by 2 pi R. That was the equation, right? If the point is outside the conductor. We have a problem here. Radius of the conductor, cross-sectional radius is given A, right? Cross-sectional radius is given as A. Look at the first point they are talking about. First point at a distance A by 2 from the center. If it is A by 2 from the center, that point is still within the conductor only, right? Radius is A. A by 2 means inside the conductor. And at the point outside 2A, it is outside. So this 2A, no complication, we can use this equation, that's fine. And inside the conductor, we have to do something, right? We have to get an expression for magnetic field inside the conductor. See, look at this. We have a current carrying conductor. We are going to apply Ampere's circuital law to find out magnetic field at a point inside the conductor. See, let me take radius of cross-sectional radius is capital R. Okay, let me consider a point here. The distance is R by 2. Okay, so that point is inside the wire, Okay, so how did we find out the magnetic field at the point? We have to imagine an Amperian loop, right? See, we have to imagine an Amperian loop of radius R by 2. Correct? Yes. This distance is going to be capital R by 2 because radius is taken as capital R, R by 2. Good. So then what about the current, Ampere's circuital law? So we can go for a mathematical expression for Ampere's circuital law. Integral B dot dl is going to be equal to mu naught I enclosed, right? Equation number 1. Integral B dot dl, we know, which can be written as B dl of theta is going to be mu naught into I enclosed, right? See, integral also, integral B dot dl, where B throughout that point it will be a constant. We have taken that out. Do you remember? Integral dl theta. What about cos theta? cos theta is going to be 1 because theta is going to be 0. Angle between dl and magnetic field. Hope you remember that case we discussed in the class. B is integral dl. B into integral dl is going to be mu naught into I enclosed. Yes. What is integral dl? Integral dl is the total length of the loop, right? Total length of the loop. So B is going to be equal to 2 pi into what is the radius of the loop? Capital R divided by 2 equals to mu naught into I enclosed. Right. See, one more point. What is B into, okay? B into I enclosed. B into 2 pi R by 2 is going to be mu naught into I enclosed. One more point. I enclosed. How will you find out I enclosed? Question says current is uniformly distributed throughout the wire, right? If it is uniformly distributed, current will be flowing through this, right? Throughout. What portion of that current will be flowing through the loop we have imagined, like, through this loop? That current enclosed is going to be equal to current per unit cross-sectional area into area of the loop. So we are going to find out in unit cross-sectional area, how much current is flowing through this conductor. That is going to be total current divided by total cross-sectional area. That current can be multiplied with what? With the area of this loop, right? Current per unit area into area of the loop will give you current through that area, which is going to be pi into R square by 4, because pi R by 2 the whole square. You can cancel that pi, and R square from either side. What will you get? We get just I by 4. Current is going to be I by 4. See, so we have I enclosed is equal to I by 4. Then you can now substitute I enclosed here. What is B? B into 2 pi R divided by 2 is mu naught into I enclosed is going to be I by 4. Just rearrange this equation to find out what? B. So what will be B? We have 2 and R gets, 4 gets cancelled from here. It is 2. So B we are going to keep here. 2 pi R is going to the other side. So becomes 4 pi R in the denominator. B into, so B is equal to mu naught I divided by 4 pi R. This is the magnetic field inside the conductor. Okay. B is equal to, I have taken 2 pi R to the LHS. We have already a 2 there. It becomes 4 pi R. Mu naught I in the numerator. So we got, this is the magnetic field inside, mu naught I by 4 pi R. Yes, let me take that as equation A. Now, what will be the distance or what will be the magnetic field outside the conductor? For that, we have a ready-made equation here, right? This distance is given as 2 times A, 2 times the radius. So 2R, R is equal to 2R. So B is going to be mu naught I divided by, what is the equation? Mu naught I by 2 pi into the distance. What is the distance? 2 times the radius, right? So 2 pi into 2R, because the second point is B2 at the point at the distance 2A from the wire. So 2A, instead of A we have taken R in our derivation, right? So I am taking, instead of 2A it is 2R. So substitute here 2R. Look at this. B is going to be mu naught I by 4 pi R. This also 4 pi R, equation B. Your question was to find out the ratio of equations B1 and B2. See, that was the question. What is the ratio of B1 and B2? We got B1 is equal to B2, right? Look at equations A and B. B1 is equal to B2. So what could be the ratio? And we have an option given, option B. Yes. So we applied Ampere's circuital law to derive expression for magnetic field at the center. Yes, magnetic field inside the wire, which we got as mu naught I by 4 pi R at a distance half of the radius. Then we found out magnetic field outside also. We have taken the ratio as per the question. We got answer 1. Okay, fine. Question number 49. Now moving on to 50. Question number 50. The potential difference across a cell in an open circuit is 8 volt. Yes, potential difference in an open circuit is 8 volt. Cells, right? It falls to 4 volt. Yes, it falls to 4 volt. When a current of 4 ampere is drawn from it, internal resistance is to be calculated. See, what is this 8 volt given actually? It is given as the potential difference across a cell, but in an open circuit. Open circuit means there is no current flowing through it. When there is no current flowing through it, potential difference is called EMF of the cell, correct? Yes, so you are given EMF of the cell E is equal to 8 volt. That is reduced to 4 volt when a current is flowing through it. So that could be the terminal potential difference, 4 volt. V, terminal potential difference is 4 volt. For what current? For a current of 4 ampere. So these are the given combination. You are asked to find out the internal resistance. You are given all other values. Easily we can find it out from the equation V is equal to E minus IR. Apart from R, all other values are given. You have to find out R. Okay, V is 4. This is 8 minus 4 into R. Right? So if you get 4R, it is going to be 8 minus 4, which is 4 only. Therefore, R is equal to 1 ohm. That was a direct question. Just have to substitute that values of E, V and I. You can easily get the correct answer. But the only point you have to remember here, it is not given as EMF in the question. Instead, potential difference at open circuit. Potential difference of a cell in an open circuit is called its EMF. Yes, only that information is enough to solve it easily using this equation. Okay, let's move on to the next, 51. A steady current flows through a metallic wire whose area of cross section is A, increases continuously from one end of the wire to the other. The magnitude of drift velocity of free electrons as a function of A. Drift velocity as a function of A. Yes, a steady current flows through the conductor. Can you just relate current, cross-sectional area and drift velocity? Yes, we have an equation. What was the equation? I is equal to N, A, E and VD. Right? It is given that, see, how will you find out VD from this? VD is equal to I divided by N into A into E. Right? That's the equation. Yes, you are given current is steady in the circuit, so current is a constant. Number density of electrons, free electrons, that N stands for number of free electrons per unit volume, right? That is constant for a given material. Yes, charge of electron is another constant. So what is the relation between VD and A? VD is inversely proportional to what? Area of cross section of the wire. Yes, so this is the relation. Then it is easy to find out the relation, right? I mean the graph, the graphical representation, which is option A. Because VD is inversely proportional to area of cross section. So we got from the current drift velocity relation only. Okay, question number 52. Now, for a metallic conductor, the correct representation of variation of resistance with temperature. Temperature dependence of resistance, right? Yes, we got temperature versus like resistance, graphical representation. 4 options are given, resistance along y-axis and temperature along x-axis. We know for any given resistor, R is going to be equal to R0 plus R0 into 1 plus alpha T, right? Resistance at any given temperature T, resistance at any given temperature T is going to be equal to R is equal to R0 into 1 plus alpha T, where alpha is called the temperature coefficient of resistance. We know R0 is the resistance at 0 degree. Yes, so we have R is equal to R0 plus R0 alpha into T, right? It is in the format Y is equal to mx plus C, where C is your y-intercept. So that graph represents a straight line, correct? C is R0, correct? R0 is C. So look at this. We have a y-intercept non-zero R0 only in option A, right? Straight line with a slope. This is the y-intercept. Okay, so option A is the correct answer. 53. A point charge situated at a distance r from a short electric dipole on its axis experience a force F. If the distance of the charge is 2r, the force on the charge will be. See, point charge is kept at a distance r from the dipole, electric dipole. See, if you have an electric dipole, see this is the positive and this is the negative charge somewhere on the axis. This is the point. Here I am going to keep one of the charge, Q naught or something. Okay, so what will be the force acting on that Q naught? Force acting on that Q naught is going to be the Q naught into electric field at the point due to the dipole, right? Because force acting on any charge in an external electric field is going to be charge into electric field strength. So Q naught into E axial. Okay, see, E axial is changed when you move from this, because that distance was measured from R, from the midpoint to that point. We are going to move this charge to another distance. What about the distance? It is 2R. We are going to increase the distance to 2R. So definitely we are going away from the dipole. Strength of the field is supposed to be reduced. But by what factor will it be reduced? That is options. Okay? Yes. So force is going to be proportional to E axial. Look at this. Q naught is a constant. So we can say force acting on that charge will be proportional to E axial. So what about E axial? E axial of an electric dipole, we know the equation E axial is equal to 1 by 4 pi epsilon 0 into 2p divided by r cube, right? If the distance r is much greater than the half of the distance of the dipole, then it is going to be 2p by r cube. Yes, r cube. Look at this. E axial is proportional to k, 2p by r cube. K is a constant. 2p is another constant, right? Yes, the electric dipole moment for the given dipole, it will be a constant. So only r changes. So if F is proportional to E axial, we can say E axial is proportional to 1 by r cube only, right? 1 by r cube. Or we can say force acting on that Q naught is proportional to 1 by r cube. We got a relation between F and R. Now we can go to the question. Yes, so from the dipole, the distance is R. At that time, this was the equation. F is proportional to 1 by r cube. So in this case, we will go for first force F1 is proportional to 1 by r cube because the distance was R. Distance was R. What is the second force about? F2 is proportional to 1 by r changes to 2r. So that becomes 2r the whole cube, right? Because it is inversely proportional to the cube of the distance. Yes, so what will be this? F2 is proportional to 1 by 8 r cube. So without further calculation, you can select the option. It is F by 8 supposed to be, right? Because we got a factor of 8. Yes, so if you take the ratio of equation 1 and equation 2, what will you get? F1 by F2 is equal to 1 by r cube divided by 1 by 8 r cube. R cube gets cancelled, 8 comes up. So we get F2 is equal to F1 by 8. So we get second option B is the correct one. Okay, so understand the question, then start solving it. Force acting on a charge, a point charge kept near a dipole. That was the situation. So it will experience a force which is equal to charge product of the charge and electric field at that point. F is equal to QE. Yes, we were taking that electric field because Q naught, same charge I am going to move to somewhere else. So only change in this equation is E axial. So we found the relation between F and E axial, which is inversely proportional to R cube. Good. So we got the correct option as B. Question number 54. Two charges plus Q each are kept to a distance apart. Yes. A third charge minus Q is placed midway between them. Potential energy of the system. Yes, we know potential energy of any charge to a pair of charges. That's a very basic equation, right? K times Q1, Q2 by R, where R is the distance between the two charges. Here you have given an arrangement of charges, two charges plus Q. This is plus Q, and I have another plus Q here. They are separated by a distance 2a. So if I go for a midpoint somewhere here, this distance is a, this is also a. There I am going to keep one more charge at the center, no, at the midpoint, what is it? Minus 2q. So this charge is minus 2q. Correct? Then you are asked to find out the total potential energy of the system. We know 3 charges are given. If there are 3 charges, there will be 3 independent pairs possible, right? If you take this as charge number 1, this is 2, and this is 3. Then we can go for Q1, Q2, one pair, Q1, Q3, another pair, and Q2, Q3, the third pair. So we can calculate potential energy as KQ1, Q2 by R12 plus KQ1, Q3 by R13 plus KQ2, Q3 divided by R23. Just substitute their values and simplify. We'll get one of the matching options. See, we can say K into Q1. What is Q1? Small q. Q2 is minus 2q. So we get Q into minus 2q. Remember, we have to take the sign of the charge when you calculate potential and potential energy, right? Yes. So minus 2q divided by A. Distance between them is A. Plus 1 and 3. 1 and 3 is QQ. We get K plus Q. One more plus Q becomes KQ square divided by, what is the distance between 1 and 3 is 2A. Yes. Plus one more, 2 and 3 combination. 2 and 3 combination is going to be K into Q minus 2Q divided by A. See, we have two terms in the same way. We have K Q square, 2K Q square by A minus plus 2K Q square by A, once again minus, plus K Q square by 2A. Just simplify. We get potential energy is equal to, see, minus 2K Q square by A, one more minus 2K Q square by A, we get minus 4K Q square by A, right? Then plus what? KQ square by 2A. Then we will just find out what will be the resultant. See, we have to take 2A as the LCM. So here we have to multiply with 8 minus 8KQ square plus, here we have to multiply nothing, so it's just KQ square only. Correct? Minus 8KQ square plus KQ square by 2A. Okay, so then what is minus KQ square plus KQ square? We get minus 7KQ square by 2A. Now look at the options. Yes, you have to substitute K as 1 by 4 pi epsilon 0. Then you will get this option as the correct one. Okay, so we found out individual pairs, 3 different pairs possible, independent pairs possible. We substituted, simplified. Okay. Yeah, so these are the questions we had in the material. 54 MCQ questions. Yeah. Thank you.